notation. Scientific notation. And the little subheading, because we've already had scientific notation, apparently is operation with small numbers in scientific notation. Operations with small numbers. We've already done this, except now we're going to start working a little bit with negative numbers. And here is your, for example, this is actually a good review for us. If, let's say you have this example. 2.4 times 10 to the negative 8th power. And I am multiplying that by 2 times 10 to the negative 3rd power. Who thinks we should make this a little larger for everybody involved? If you remember, turn the Wayback Machine way back. How do you multiply numbers in scientific notation together? Some of it is logical and parts of it are not quite as much. But there are some simple little rules. They're written in your notes, so you should know. Evelyn, the first thing you do is...
You multiply the first...
Yeah, you multiply the left numbers together. You are going to multiply these two numbers. And 2 times 2.4 is pretty simple. It is 4.8. And it's at this point, ladies and gentlemen, okay, that you look at this number. And I mean, this is like a little thing. If you get 4.98, is that acceptable? It is, because it's between 1 and 10. If you get a 48, in the back of your mind you should say, I am going to need to change this later because 48 is not between 1 and 10, and all scientific notation numbers have to be between that. So this is good because it means we don't have to do any more work at the end, but it's always good to realize. I put times 10 in there, and then the deal is I need to figure out what is going to be my exponent of 10. What do we do when you multiply in scientific notations? What do you do to those exponents of 10? What do you do, Amelia?
You add.
You add them together. So you have to think about this. Burp and burp. If I take a negative 8 and add a negative 3 to it, what do I get, Jacob?
Positive 5.
I don't get a positive 5. I have 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8, and I put 3 more negatives with it. I've got no positives. I actually have, Jacob, let me give you those. Negative 11. Negative 11. And that would be your answer. Again, it's okay. It's good because this number is between 1 and 10. If it wasn't, then you'd have to do a little bit more work. Now, I want you to think a little bit about what we're doing when we just did this. What did we just do, and why is this easier than just doing it out the normal way? Well, if you think about this, what is 2.4 times 10 to the 8th power? If I wrote that out in standard form, in normal numbers without scientific notation, what would it look like? Anybody care to speculate what 2.4 times 10 to the negative 8th is as a decimal number? Well, you have to move the decimal 8 places backwards. The 2 takes up one of the 8, so you have 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, and then you have the 2 and the 4. And you are multiplying that by, what was this, a 3? Move the decimal, starts here, comes back 3 places, 0.123. Okay? And you multiply that. 2 times 4 is 8. 2 times 2 is 4. That's all the digits. You can write all those zeros. How many decimal places need to be in my answer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, but you said, I might get a negative 11 there. Well, 12 places means I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Decimal goes there. How many zeros do I have there? I think 10. 1, 2, 3, 5, 6, 7, 8, 9, 10. If I'm changing this number back into scientific notation, where do I have to put the decimal? Amelia?
Between the 4 and
Okay, so I put it between the 4 and the 8, and then I put times 10. How many places did I move the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11. I just did this and got this whole thing when this was is this not quite a bit more simpler and quicker and easier than doing all that? Tell me if good. Yes, but that's what you did when you multiplied that together. Let's have another example you would have. How about do a division one? 4 times 10 to the 8th. I'll let you get my glasses. Okay, well, hold on. Don't write that down. I can do wrong. You can't make it. You know, you turn 50 and the whole world starts collapsing. I could guess, and it really doesn't matter. I can think of mine. I want to kind of be consistent with your book there. 4 times 10 to the 8th. Getting to negative 8. Yep. 4 times 10 to the negative 8, 2 times 10 to the negative 2. How do we do division with those numbers? Abram?
subtract the negative 8 and negative 2.
Well, not to that point yet. We'll deal with the numbers first. What do I do with these? Huh? What's 2 goes into 4? Twice, which is good because you get a number between 1 and 10. You write down 2 times 10. And then what do you do when you divide exponents or bases that have exponents? Evelyn? Subtract. And here's where you have to be careful, people. Take some time to think about this. I am taking negative 8 and I am subtracting a negative 2. Negative 8 minus a negative 2. What happens when you subtract a negative? You get 2 of the same signs next to each other. This actually becomes negative 8 plus 2, which means I have 8 negatives, I have 2 positives, and Wade, you end up with? Negative 6. Now let's do a couple more, slightly more complicated ones there. Let's do another division one. 4 times 10 to the negative 8. Divided by 5 times 10 to the negative 2 power. And here we go. If you know your fractions, you can tell me what this is. What is 4 divided by 5, or what is 4/5 as a decimal? 5 goes into 4. Put a decimal point there. It is 0.8. Here's a red flag, if you will, that's not between 1 and 10. You are going to have to deal with that at the end here. Times 10 to the what power? Again, you're bringing this as a division, so you subtract. It's negative 8 minus a negative 2. And a negative 8 minus a negative 2, Amelia?
It's really negative 8
Plus 2, yep, which is?
negative 6.
Negative 6. And then here's where we must pause, take a deep breath. And you should write these down and you should look back in your notes because it is not something you just remember because we don't do it. It's not like you do it every day so people forget it and then they don't remember when they do it. All right, how do I make this number between 1 and 10? Parker?
8.
Huh? I need to
Put it over 1.
move the decimal here to make it an 8. But if I change this number, my exponent has to change. What do I do to that exponent?
Subtract 1 from 6.
And you get?
Negative 5.
Now, maybe this is a way to remember it here. What did I do to this? To move this decimal, I actually multiplied this by 10, right? Well, if I multiply this by 10, I actually multiply it by 10 to the first power. Which, in fact, if I make this bigger, wait, is that right? No, I think I have to go opposite. Sorry, don't make that. If you make this one bigger, you have to make this one smaller. And what is a negative 6 minus 1?
-5.
Nope. Huh?
Positive.
Nope.
-1.
You have 6 negatives, and you have another negative.
-7.
It's negative 7. If you make this bigger, this you have to subtract. Whatever. You think the opposites. Let's see what else. There's got to be another one here. Let me give you one to try here. How about this? 1.2 times 10 to the 8th. Apparently they like the 10 to the 8th. 1.2 times 10 to the negative 8. All divided by 4 times 10 to the, I'm sorry, yes, 3 times 10 to the negative 4th. 3 times 10 to the negative 4th. Tell me what you get. You do this all the way out. And the trouble is going to come because it doesn't give you a number between 1 and 10. Then you're going to have to change it. Perdão? Abram?
Yeah, 4 times 10 to the -5th power.
Well, let's see. Let me do it here. If you take 3 into 1.2, you get 0.4, correct? Times 10. I move this up and it's subtraction, so it's minus a negative 4, which is actually plus 4. So I get a negative 4 there. I make this, move this 1 and make it 1 bigger, which means I have to do the opposite and make that 1 smaller. 4 times 10 to the negative 5th is correct. Everybody get that? Try to figure out why that is, why that isn't, who it could be, who it couldn't be. Oh, one more. Let's do one more. Let's do a multiplication one, you say.
Let's do a multiplication.
Yes, let's do that. 7.5 times 10 to the negative 3. I'm going to multiply that by 2 times 10 to the negative 5th power. Let's give that the old college heap ho. Let's give that the old college wisdom a try. What did we come up with?
I cannot draw that well.
Me neither.
Or
1.5 times 10 to the -7.
let's see. This times this gave me 15, right? times 10, add exponents together, -3 to -5 is -8. Boom, I move this one place backwards and make it 1.5, I'm good with that. Now here you made this one smaller, so you have to make that one bigger. -8 plus 1 is a -7. Yes? Always think opposites. If your number becomes bigger, your exponent becomes smaller. If your number becomes smaller, which this did, your exponent